Okay, the next group of OCXOs, specialty OCXOs, is the ultra-stable DOCXOs. DOCXO stands for double oven, which means the oscillator in the crystal circuit is in an inner oven, being controlled by an inner oven control structure. There's an outer oven that controls the temperature that the inner oven sees or senses. Instead of, say, plus or minus 1 degree change on the crystal and oscillator components that you normally see on a single oven, a regular OCXO, you now see 1 millidegree, 2 millidegrees, 5 millidegree total temperature change on the crystal in the oscillator, because now it's being controlled within a controlled environment that's also being controlled. So you have double control over the temperature change of the crystal in the oscillator circuit. That is why you're able to achieve 1 or 2 parts per billion stability over operating temperature versus, say, 10 or 20 or 30 part per billion stability. Now, double ovens, or what some people call super single ovens, 1 or 2 part per billion stability, minus 40 to 85. Depending on the application, the OCXO will either be a tremendous single oven or it'll be a double oven. And also a function of that will be what the expectation is from the customer in terms of total frequency change in a year or over 15 to 20 years in the field. Single ovens and double ovens come in 5 volt or 12 volt. Some of the older designs, 20, 25 years ago, come in 15 volt design or even 28 volt design. In old legacy packages, the double ovens had 2 different DC supplies. One DC supply would feed the DC oven control circuit, say with plus 28 volts. The RF circuit, the oscillator circuit, and the output amplifier, buffer amplifiers, those were all controlled by, say, a 12 volt DC supply. So in the old designs, you had dual supply feeding the double oven product. Mainly, double oven or ultra-stable products are of the 5 or 10 megahertz operating frequency. Usually the reason of that is the lower the frequency of the precision crystal, the lower the frequency, the more stable the SC cut or AT cut crystal is for long-term stability. Just the crystal itself that's used inside the oscillator. So traditionally, and even to this day, 5 or 10, sometimes 15 or 20 megahertz are basically the limit on the frequency for a double oven product. Now, for example, the OCXO 3182-X39 is a 5 volt low power double oven. It has technology inside of it that has very low power consumption on the inner oven. So the total power of the double oven looks as though it's a single oven product. And it gives us 3 part per billion stability minus 40 to 85. So applications requiring 1 or 2 part per billion over temperature usually go hand in hand with total aging per year of 15 to 30 parts per billion per year, total aging. 1 part per million is equal to 1,000 parts per billion. So an OCXO stability, in general, is 1,000 times more stable than a TCXO. The catch, though, in OCXOs, and I don't even have it listed here, for double ovens, if a customer needs a double oven oscillator, they're not worried about how much power consumption the double oven takes, because these kind of products only go in very large infrastructure products, big frequency standards or base stations, VSAT terminals. Double ovens, those kinds of engineers are not concerned about power consumption usually. They have plenty of power budget to allocate to the OCXO product. We are very strong in the depth of our products that we can offer in double ovens, but as you can see, most of the time the packages are pretty large. The 36 by 27 millimeter footprint is a Euro case or Euro package style, mainly used in Europe. The 20 by 20 millimeter is now gaining popularity all across the world. In the US, the 25 by 25 millimeter is a very popular package size as well. But you don't see too many double ovens in those smaller sizes. Still in the United States you see, and we don't even have any listed here in our double ovens, 50 by 50 millimeter, 2 inch by 2 inch, is still a traditional double oven type size. So 1 to 2 part per billion. These tend to be used in applications, for example, GPS modules that have an oscillator on board, and it is phase locking to a GPS signal using a GPS receiver chip. Lots of instrument companies build very sophisticated frequency standards. Inside those frequency standards are GPS receiver chips, a couple double ovens, and this overall box, this overall instrumentation box, feeds out multiple outputs that are very stable. Those are generally used for big systems, GPS synchronization systems, timing systems, or laboratory use for frequency standards. Not going to be a lot of double oven opportunities. For every 5 OCXO opportunities or 7 OCXO opportunities, there'll be 1 for a double oven. What is emphasized, again, in double ovens is the stability over temperature and the long-term aging. Usually, the phase noise floor is of little importance to these type of applications, but the close-in phase noise related to short-term stability can be of primary importance. The root Allen variance or Allen deviation or short-term stability. There are many different terms that customers will use to describe what they need for short-term stability.